Hi, guys. Hi, Emmy. Hi, Addie. Hi, Leon. Hi, Lucas. Hi, Toby. Hi, Ruby. Hi, Arya. Hi, Mackenzie. And hi, Asa.
Told you.
Hello. Good to see everybody. Let's do it. Please remember, if you are just joining, to grab that Nearpod link. I would like to see everybody in the Nearpod if possible. And Arya, are you ready to repeat after me our Zoom expectations?
Mm-hmm.
Okay, go. Participate.
Participate.
Be respectful.
Be respectful.
Be on time.
Be on time.
Microphones muted.
Microphones muted.
Include your name in the Zoom window.
Include your name in the Zoom window.
Stay seated.
Stay seated.
Eyes on me.
Eyes on me.
Good work. And what is today? You read the little box. Today is Thursday.
Thursday, April 6, 2023.
Fabulous. Thank you so much, Lovebug. You can go ahead and mute, and we will celebrate our birthday friends, our April birthday friends. Ava, Leon, Avery, Dr. Tyler, and Miss Addie. Fabulous. Give them some monkey claps, guys. Woo-hoo-hoo-hoo. Nice work. Oh, wait. Come back. Oh, there she is. Oh, I almost forgot Mackenzie. Oh, I would not forget Miss Mackenzie. So we have a bunch of April birthdays. Let's do our Zoom promise. Miss Fayruza, awesome Zoom promise keeper. If she's here today, she will help us choose a game. If not, we'll postpone it for another time, or or if we run out of time. Carter for amazingly detailed responses, and Ruby for working hard, keeping up with all her work. Guys, let's get right into it. Let's jump right into this Nearpod today, because this is an important one for us. And I'm going to join you over there right now. And if you are just joining us, the Nearpod link is in the chat. And we're going to talk about what is an array today. Ooh, that rhymes. What is an array today? We're going to discuss. Whoops, hey, go back over. Oh, look how many friends I have in so far. It says 9 so far. That's awesome. Okay, so in your module lessons, and maybe what you're learning at home with your learning coach, we've been talking about repeated addition and creating an array to help us understand what repeated addition is and how it's related to multiplication. Multiplication. So some of you have already a little head start on it, which is great. You can help us understand what is, think about it, what is repeated addition, repeated addition, repeated addition, repeated addition. Oh no, she's in a loop. What do you think repeating means? Addie?
Over and over.
Over and over and over.
Puppet.
Nice. That's right. So repeated means it happens over and over and over again, and it happens the same exact way. So what do we know? We know that arrays show data in rows and columns. It helps us understand how, and we can organize it. I like that word. Organize our data in rows. Show me a row, show me a row, show me a row, and a column. Show me a column, show me a nice tall column. Good. So rows and columns, it helps us see it clearly. It helps organize the data, and it helps us understand how things repeat over and over and over again. Then we will discuss how can an array help us solve repeated addition problems. So let's jump into it. First, tell me what you know. How much do you already know about solving repeated addition problems, repeated addition problems, repeated addition problems, where the numbers happen over and over again? A, I know a lot and can explain. B, I need a little practice. And C, help. I need instruction and support. What's addition? What's repeated? Oh, some of you think you know. Oh, I like that. All right, maybe you guys can help me. All right, let's go on, watch a quick little video. This lesson has some video, a little bit of practice, and then a big exit ticket at the end. Yeah, it's actually a really cool lesson. So let's watch only a few minutes and have this monster explain what repeated addition is and how we can represent it using arrays.
Welcome to kidsacademy.mobi.
Keep your eyes on the screen.
Hello, everyone. Picture.
Skip to a good part. Okay.
This
there.
will make the adding a lot easier for us because we'll just be adding the same number over and over again. We'll start to see a pattern.
Pattern.
Here we have a group of apples. Let's count them carefully, one at a time, to make sure you know how many there are. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 apples. This problem can be easily represented in 2 different addition problems. First, we can count the top row across. 1, 2, 3, 4. Okay, that's 4. And then the bottom row. 5, 6, 7, 8. And that's 4 too. Both the top and the bottom rows have 4 numbers. This problem could be represented by 4 plus 4. And we know that 4 plus 4 equals 8.
Okay, let's stop. Oh, hey,
There's another.
let's stop there for a second and talk. Let's talk about this. Now, which one is more efficient? Okay, this is the first question I want you to talk about. Which method is more efficient? Counting every single apple one at a time till you finish, or grouping them into equal sets and just doing, oh, well, 4 plus 4. Which one's more efficient and why? Efficient means fast and correct, right? Okay, so Isaac, who do you want to talk to? Isaac, do you want a friend? We have a lot to do, so pick one.
Emmy?
Okay, Emmy. You guys discuss which method was most efficient, one at a time or adding by groups.
They're adding grouping it together because you can find groups. Yeah, I agree.
Keep talking.
It's like they kept adding and they saw it was 4 plus 4 is 8 altogether.
Mhm.
So, but that's actually a plus problem. So you have to add 4 plus 4. It's an addition problem.
So do you think that's faster, guys, than counting one at a time?
Yes.
Okay. So you noticed a pattern? And your pattern was, I think I heard your pattern was 4 on the top, 4 on the bottom.
4 on the bottom, and that equals 8.
Wonderful. Great job, guys. Thank you for sharing. I think I might agree with you that noticing a pattern and adding in groups is going to be a lot more efficient than counting one at a time. So, all right, now, another quick question before we move on. This is what's called an array, by the way. Lining them up and showing the groups is an array. Remember rows and look at the columns. Quick, look at the columns. In the problem that he showed us, it was 4 on top and 4 on the bottom. Who thinks they can determine a different pattern by looking at the rows? Anybody think they can tell me how many? Ooh, Asa? If I looked at it in rows, how many are in each row? Sorry, oops, whoop, take it back. If I looked at it in columns, how many are in each column?
There are 4 in each column.
4 in each row. Remember, rows are different than columns.
2 in each column.
2 in each column. Good. Now wait for me. If there's 2 in each column, let's count. There's 1, 2, and then there's 1, 2, and then there's 1, 2, and there's 1, 2. How many columns do we have?
8.
Oh, do we have 8 tall columns of apples? Take your finger and go 1, 2. How many? 4 columns. That's right. So we are doing 4 columns, and in each column we have 2. Oh, so you know what the repeated addition problem would be? 2 plus 2 plus 2 plus 2. Oh, I get it now. And that is 2 in each column, and it's 4 times we have to count them. 2 times 4. Oh, it's multiplication. So I wanted you to see it a different way. So real quickly, let me give you the annotate, guys. Here's a column, here's a column, here's a column, here's a column. So instead of doing rows, which are across, we can also, remember where they did rows before, we can also separate it a different way. We can do it 2 plus 2 plus 2 plus 2. That's still a pattern, isn't it? Is that a repeating pattern? Is that a repeating addition problem? Yes, it is. Okay, so you can do it both ways. Which one's most efficient? 4 plus 4 or 2 plus 2 plus 2 plus 2? Mackenzie, who do you want to talk to?
I'll talk to Addie.
Okay, unmute. Discuss which repeated addition problem was most efficient.
4 plus 4 because it's not as much you need to count. Because like normally when I have to count and add stuff together, and there's like stuff like apples or like circles, and there's the same on the bottom and top. I just count the top, and then normally, like if it's 5 or 4, I know 4 plus 4 is 8, and 5 plus 5 is 10, or 2 plus 2 is 4. So there's lots of different ways.
Addie?
Yeah. Like if we have cookies and there's 4 cookies plus 4 cookies, that will be, if there's like 4 cookies plus 4 cookies, I know that's 8.
There's like 4 plus 3, then you would add 4 plus 3. So it would be 4 plus 3 equals 7.
Mm-hmm. Awesome. So you
Or
guys
other
agree
numbers.
that the fewer groups, we can have more in a group, but we just have to count fewer groups. That might make it more efficient than counting more groups and they have less in each group. So 2 plus 2 plus 2 plus 2 is not as quite as efficient as just grouping them together in larger groups, 4 and 4, right? Is that what you're saying?
Yeah.
Okay, nice work, guys. Thank you. All right, let's go on to, let's look at this one real quickly. All right, guys, let's discuss who wants to go next. Oh, let's try, who hasn't gone yet? Oh, Ruby, and maybe you want to pick somebody, Ruby? Okay, so here's your question. Listen first. I'm looking at the pairs. We have organized the groups of pairs. Which, and I see the array of pairs, which math problem or addition problem matches how we grouped the pairs, what the array looks like, which math problem matches?
So I think it's 2 plus 2.
Who do you want to talk to?
Mackenzie.
Okay.
I think it's 2 plus 2 plus 2 and 3 plus 3. Because in the columns, there's 2 in each column. And the rows, there's 3 in each row. Yeah, I agree with Ruby because there's 2 in each column and 3 in each row. So both of the answers are right.
So we can either do top and bottom, 3 plus 3, which is way more efficient than counting one at a time, or we could do the columns, 2 plus 2 plus 2.
I like the rows better because there's a least amount that you have to add together.
That's right. Ooh, you guys are really on it. Thank you very much. I told you could help me teach it. Nice work. All right, guys, let's move on to some practice. Thank you for helping me discuss that. All right, take a walk around the grocery store, and we're going to pay particular attention to the oranges. Look at all those oranges. That's a lot of cuties. Look at all of them. Do they have them grouped? Are they grouped? Yeah, they have them in little boxes or baskets, right? So they have some in each basket. If they were equal in each basket, could we do a repeated addition problem? If they're equal, okay, yeah. Remember, repeated addition, they have to be equal groups. So if this one has 6 and this one has 20, that's not equal, is it? We have to make sure we're matching or we are evening out to be sure that each group has the same. Okay. So that's what we organize, just like they did the oranges to show, and this, you can actually think of this like an array if they're equal. Okay, all right, so let's ask you a question. Remember, it's practice time. Let's pretend that there are 3 baskets of oranges. Each basket has 5 oranges in it. Each one has 5. How many in all? Draw an array of oranges to represent the total number of apples. So it's a 2-part question. How many apples in all? And can you draw an array to show? Oh, it's got more than that. It's going to have more than that. Ooh. Okay, remember, there are 3 baskets. So if you're just typing in the Zoom chat and you're not figuring it out on this board or on a piece of paper, then chances are not going to get it right. So make sure, I'm going to go peek and see how people are doing, that you're trying to work it out. Oh, look at Emmy's. Emmy, is that adding or subtracting? Tell me. Oh, she says adding. Yes, that is an addition problem. Lucas, look at you. Ooh, Asa says 15 in all. Is that addition or subtraction? Can you show me the problem? Like write the equation? Okay, so let's talk about this for a second. There are 3 baskets. I should have made this draw it. There are 3 baskets. So I'm going to go ahead and annotate so you can see it. When I was a little kid, I liked to draw the baskets and I would put the little oranges in the baskets. 1, 2, 3. Each basket has 5. They are even and equal. And now I can show 5 plus 5. Who put 4? Who said there were 4 apples? I didn't say there were 4 apples. I said there were 5. 5 in each basket. So what is our array? 5, 5, and then another 5. 5, 5, 5. Oh, I can arrange it. And if you show an array, it looks like you could do it in rows or columns. 5, 5, 5. 5, 5, 5. Count by 5s. 5, 10, 15. How many in all? If you said 15, you got it right. How'd you guys do? You did it? Are you happy with your answer? Yes. If there's a subtraction sentence, then it probably would not connect to this lesson, because this lesson is about repeated addition. What's addition? Adding. So if I see a subtraction sign, you might be thinking about something else, something different. Beautiful. I love those pluses. Okay. Great practice, guys. Here's your exit ticket. This exit ticket will help you measure what you've learned so far. Think about, where is it? Go back to it. All right. Look at the little cute box up here. How many in each, let me see. You can do rows or columns. I think they want to know how many in each row. Okay, so count how many in each row and see if they're all equal. And then find the addition problem that would match that array, that beautiful array of lined up data. Okay, you're done with that one. And you show how you're adding each row. Can't wait to see how you did. All right, and go to the next one. Look at this one. Ooh, look how easy this one is. Let's count the rows. How many are in the top row? How many are in the second row? What math equation could we use to represent that array, that data? Ooh, boy, oh boy. I see some right answers. Let's look. Okay. All right, moving on. I have some people who are not answering. I'm coming to eat you for dinner. Ruby, are you unable to answer the problems? How about Lucas and Leon? Is it giving you a hard time? You can't do the Nearpod?
I'm answering them.
Oh, maybe it just isn't showing up yet. Okay, I'll keep checking. All right. All right. Now, if I see some reds, you know what that means? If I see your answers are not correct and they're showing up as red, that means we need to practice some more, doesn't it? We need to have better understanding of what an array is. Okay, guys, get right to the end. If you want me to read number 3, you can go back to number 3 and I'll help you. Michael drew an array that had 3 rows. Each row had 2 circles. Which array matches what he drew? Remember, it had 3 rows and each row had 2 circles. Which array matches? That was number 3. 3 rows, row, row your boat, okay? And then 2 in each. Now, next one, number 4. Mackenzie, you good? Abby went to the store. Go ahead.
I was gonna say I only see the right answer in B because it's in columns. I don't see it in the other ones. I see in D it is, but it has 3 columns.
What number? What number?
So on
Number 3?
3, it
Okay.
says it's supposed to be 3 rows. So in 3 rows, it's number
3.
D, but then it says it's supposed to be 2 columns, and there's
2 in each row. 2 in each row. So let's look at B. Here's a row and it has 2. Here's a row, it has 2, and here's a row and it has 2. And let's make sure. Yep. Guess what? I know I can prove my answer by going back in the text. There's nothing there that says columns. So then I know the word columns doesn't appear. So I know that they don't need columns. They just want to know about the rows. So B is your correct answer because it has 3 rows and 2 little circles are in each row. Okay, that's why I think it's B. All right, let me go ahead and move on. Oh, whoa. What'd you do, Miss Cruz? Don't do that, Miss Cruz. We're on number 4, I think. Abby went to the store and bought some donuts. The donuts were organized in an array. So picture you got donuts from the store and you lined them up in an array. And it had 2 rows and there were 4 donuts in each row. So pretend to line them up. There are 2 rows and each row had 1, 2, 3, 4 donuts. So which equation would we use? 1, 2, 3, 4. 1, 2, 3, 4. I hope I hope you got that one right. Ooh, that one was a little tricky, wasn't it? Number 4. Okay, listen, 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 Linda's 4 donuts. 1, 2, 3, 4. Wait, this reminds me of the video. 1, 2, 3, 4. 4 on top and 4 on the bottom. What equation shows 4 and 4? Okay, number 5. During the parade, the band marched down the street in an array with 5 rows. 1 row, 2 row, 3 row, 4 row, 5 row. Each one of those rows had 3 band members, 3 marchers. How many were there in the array? Oh, total. 5. Oh no, each one had 3. So 3, another 3, another 3, another 3, and then the 5th row, another 3. How many in all? That's our question for number 5. Got some answers coming in. Let me peek. Okay. You could also flip that around and do, instead of 3, 3, 3, 3, and 3, adding 3 5 times, you could add 5 3 times. Okay, moving on. Number 6. Look at that beautiful array. Which repeated addition problem or equation matches that array? So let's see, we got 4, and then another 4, and then another 4, and then another 4. Which one matches? That was number 6. Everybody should get that one right. So sad. Look at number 6 again. If you guys go back to number 6, 4, and another 4, and another 4, and another 4. Ooh, look at that. They all match up, and that is 4 rows, and each row has 4 dots. Okay. Number 7. Look at that beautiful array. Wait a minute. What repeated addition matches that array? Let's see. How many columns does it have? I mean, sorry, how many rows does it have? Oops, I got it backwards. It only has 1 row. And how many are there in that row? Are there any other rows? Ooh, tricky, tricky, tricky. Oh no, this one's a tricky one. Guys, go back to number 7. Quick, I've got the answer for you. Ready? All right, so here's our first row. How many do I have in there? 4. What's our second row? What's our second row? How many?
0.
Zip, zip, 0, zilch. Are there any other rows? No. So what's our final answer? Go back and mark the correct answer for that. It only had 4 plus no more. 4 plus no more. Mark that answer. I hope you fixed number 7. That was important. The correct answer should have been A. There was 4 and no more. Okay, let's do number 8. Elizabeth planted a garden. Ooh, I know somebody who's going to plant a fairy garden. She planted 5 rows of flowers. 5 rows. 1 row, 2 row, 3 row, 4 row, 5. Each one of those rows had 5 flowers in it. What equation shows how many flowers she planted? 5, another 5, another 5, another 5, and another 5. That's 5 rows, 5 times. Did we get that one? Couple people got it right. 5 rows, and each row had 5 flowers. How can I draw that? Easy peasy. Here's a row. It said 5 rows. There's my rows. Guys, if you got 8 wrong, go back. Here's my 5 rows, and each one had 5 in it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oops, I'm getting a little sloppy. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a lot of fives. Correct answer should have been, what is it? Oh, somebody said C. That was for number 8. Number 8, 5 rows, 5 times. 5 rows, 5 times. 5 in each row. Okay, 2 more. Oh, let's look at the cars. This should be pretty easy. It's easy to notice how many rows. We have 1, 2, 3. How many in each row? 1, 2, 3, 4. Okay, 4 cars, 3 times. What repeated addition sentence matches the array of toy cars? If you picked D, that doesn't even, that's illogical. 3 plus 3 plus 3 does not equal 12. That doesn't equal 12. That doesn't even make sense. Okay, let's see how you did on number 9. Ooh, most people got it right. It was A. Good work. Love it. 4 plus 4 plus 4. Okay, now let's look at number 10. Last one. What repeated addition sentence matches the panda bears? Okay, so how many rows do we have, guys? On number 10, show me with your hands. How many rows? How many? 2? Yes, we have 2 rows of panda bears. The top row and the bottom row. How many in each row? Show me with your fingers. How many pandas in each row? 4. Yes. Okay, good. Now, this looks just like our video. How many on the top plus how many on the bottom? What is our equation? Yeah, Mackenzie, good work. The repeated addition problem is 4 plus another 4. 4 2 times. 4 on the top, 4 on the bottom. 4 plus 4. That's it. If you didn't get D, 4 plus 4. Most people got it. That was awesome. All right, loves. I don't know why a couple people aren't showing up, but no worries. We almost done? Yeah, we're almost done. We should probably skip this part. Okay, now this is a bonus game. You are welcome to stay if you'd like. This is a game that I would like you to practice with your learning coaches. And it says, how do arrays help us understand and solve not just repeated addition problems, but multiplication problems? All right, so this is like a little game. I'm going to share it with you later too, but it says to find the product. Whoops, is it coming? Hold on. Hold on. It's thinking. Okay. Can you see me type the number? Oh, yeah, there it is. Can you see oh, look at Emmy. She's got the cards. Okay. Guys, this is how you play this quick game. It's kind of new to me, so I'm learning it too. But you'll see an array colored in the middle of the grid, and you'll see 1, 2, 3 rows colored in. Can you see the 3 rows? One has 4 in it, the next one has 4 in it, and the third row that's colored in also has 4 in it. That's 3 rows, and each one has 4 in it. So our math problem that's related, or our multiplication problem that's related, is 3 times 4. 3 rows, and each one has 4 in it. And you would just type in the total. If you're not sure, one way to do it is just to count one at a time. You know, the least efficient way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You type in 12, you submit, and if you get it right, he does his dance. And now we'll look at the next one real quick. 4, 4, 4, and 4. Look again. 4 and 4 and 4 and 4. That's 4 rows 4 times. 4 plus 4 plus 4 plus 4. The multiplication problem that is related to that is 4 times. 4 times 4. And you can do your repeated addition. 4 and 4 is 8, plus another 4, 12, plus another 4, 16. Or you can practice knowing your multiplication facts, 4 times 4. All right, and then you submit. And he does his dance. So I only wanted to show you that real quickly because I want you to understand that repeated addition, you can use arrays to help you not only understand, but to solve repeated addition problems. And those are related to multiplication. We can take a repeated addition problem, shorten the way we write the problem out, and instead of 2 plus 2 plus 2 plus 2, that's 2 4 times, 2 4 times, we write 2 times 4. I just wanted to show you that. Okay, this one's actually 2 plus 2. 2 times 2, I mean. 2 rows times 2. 2 and 2. 2 times 2. Woo! Wow, it's a lot to teach you, but this part of it is an extension piece. I want you to practice this with your learning coaches so that you understand that arrays are related to multiplication. All right, guys, I think we are totally done today. Yeah. Oh, give me your poll.
Ms. Cruz, I have a question.
Okay, I'm coming to you in a second. I have your poll. If you're still here following today's lesson, are you feeling a little bit more comfortable about arrays and how we use arrays to show repeated addition problems, math problems, addition problems? Oh, I see a few more friends in the A. And 5. Everybody mark your answer. How are you feeling now? A couple more people in the A. Listen, if you were getting remember the quiz we had, if you found that you weren't as comfortable, please practice this later today. And then you can also sign up with a help session for me. And also, I will be going over this in another lesson coming up soon. So, must have been a good lesson. I see a few more people in the A's. And let me ask who had a question. Look at Emmy. She's got every multiplication tool. But wait, who had a question first? That was Leon? Okay, Leon.
I got the question wrong because